Okay, hello students. Here I am making a video on Algebra 2. This is Unit 1 and the lesson is different type of sequences. So working on the practice problems in this lesson. So if I click on here, mm, so this is a cumulative practice problems, and here it is. What I did was I tried to copy paste it in the Smart notebook. Here it is. So the first problem of the day, and there are 7 problems. So let me walk through each one of them. The first question is is here are it says here it is. Here are first 2 terms of some different arithmetic sequence. So it talks about arithmetic sequence. So the first one is let me write -2. So the first one, oh, let me take the pen. So -2. So the very first one is, says, it means the first one is -2. I like to always make a table like this, where you have first one, the second one, the third one, and so on. Can I write properly? So that means this one, the first number is -2, the second one is 4, and then the question is, you can see, because it is arithmetic sequence, that means there is a rate of change. So what is the rate of change when the step number increases by 1? And you can see from here to here, you want to see what's adding to -2 to go all the way to 4. And you can see it is 6, right? Or there's another way to do is you take 4 and you subtract any term, that means 4, you sub 4 and you take away -2 and you get two negatives. Two negative makes it positive, so you get 6. So that's another way. So that means you're adding +6. So here are the first 2 terms, and you're supposed to write down the next 3 terms. So the next 3 terms would be, okay, you add +6, and this becomes 10, and then add another +10, +6 becomes 16. That's all they're asking you to to write the arithmetic sequence. What about the second one? Uh, the second one is there's a 111. So that means if you see this part, 111, so you're adding 100 here. Can you see this? So you add 100, so it is plus 100. So you're adding plus 100. So that means again you add another plus 100. So that means 211, and then again 311, and so on. So it's very quite easy. I don't want to spend too much time. And you can see the C is starts with 5, then 7.5. So naturally they are adding 2.5, and then again you add 2.5 to make it 10, and again you add 2.5 to make it 12.5, and that's how you finish the third one. What about the last one is -5. So this one, let me make a table for the last one. And let's take only first, second, third, and the fourth, right? And the number is first position is 5, and then the -4. That means this is n. That's our step number. Which position? The first, the second, the third, and the fourth. And I can even call this as maybe bn. So b of n. That means the name of the sequence. So what adds here? What adds here? You can see the only way to get negative, it means on the number line. So it's like it was at -4 and you go all the way to 5. So it's altogether 9 if you see this, right? So that means what adds to -4 to do that. So another one way to do is -4. So this -4 minus of, so let me do one more time. So the number starts with 5. That's what I forgot. So this is the start, and you go to negative, you go backwards, right? So you have to add a minus 9, even though it is 9, but you're going backwards, so minus 9. So minus 9, so it was, so it's the 5, and you're adding plus 9, and that is negative 4. So each time you're adding negative 4. So you add another negative 4, uh, sorry, negative 9, you're adding negative 9, you add another negative 9 here. So negative 4 and negative 9, that will become negative 13, and then another negative 9, so that will become negative 22. Let's do the second problem. Watch this. In each of these, you can decide, do you think it is arithmetic or geometric sequence? How do we know arithmetic is? That should be a rate of change here. That means you need to know the common difference, and for the geometric sequence, you should have a growth factor. That means should be a common ratio there, and this is common difference. If you see the first one, 200, let me see, 200, and then it is 40, and then 80, and clearly you can see that, and this is like n. I can just give a name to the sequence and say, okay, let's call this as a of n. And you can see from 200, and the difference is quite a lot. See the difference 200 to 40, this difference is so small, so it cannot be the same thing. I'm checking for what multiplies here. So let's check 40 divided by, in order to know what multiplies, is it the same thing? Another way to do is you take this 40 and then divide by this 40 divided by 200. So when you work this out, you can see divide by 10 both sides, and you get 4 over 20, and again divide by 4, and you can clearly see that's like 1 over 5, so you get 1/5. So that means the first one is 1/5. So from here you multiply 1/5. The question is it also 1/5? Are you really multiplying 1/5 here? So that means I have to check 8 divided by 40, and you can see 8 goes 5 times 40, so 1/5. That means it's a common ratio, yes. So this is a geometric sequence where the common ratio here, R, is 1/5, or the growth factor is 1/5. Then the next problem is 2, 4. See, clearly you can see that uh, it looks like, let's see, check this one. If I want to know really true, it looks like the difference is not the same. So not it cannot be arithmetic sequence. But is it a geometric? So 2 times 2 is 2 multiplies 2 is 4, and here it is 4 times 4 is 16. So naturally, if it is 2, 4, and 16, this one you are multiplying 2, and here you are multiplying 4. So this and this is not the same. So the R is different for the first one to the second one is 4. So they are not the same. So that's neither arithmetic sequence nor geometric sequence. So we can write here. So this is neither arithmetic sequence nor geometric sequence. The next one, clearly, see these numbers are 10, 20, and 30. By just looking at it, you already know the answer. It is adding a each time plus 10. And that's the rate of change, which is D, or the common ratio. And that's why this is arithmetic sequence. The next one, if you see here also, is the same as the first one. The only thing here is you're given 100 and 20 and 4. That means I want to know. So there are 3 terms here. So I'll write 1, 2, and 3. And you can see what multiplies here. So you just do 20 divided by 100. And you work it out, you get 1/5. And the same is 4 divided by 20. And you work it out, you get 1/5. So both are 1/5. It means you multiply 1/5. That's the growth factor. You multiply 1/5. Here also, that means it's a geometric sequence. So, and the last one is, I make a table like this. Okay, let me take a separate table. Just have a, okay, so one, the second one, the third one, and this number is 6. First one is 12 and 18. I can call this as one A, B. This is E, right? So I can call this as E of n. That means the number at the nth position. So the number at the first position is 6, and you see multiply by, and you can see 12. Always start with the second one, divide by 6 is 2, right? And the 18 divided by 12, if you see this, the 6 divided, so 3 over 2. So this is not the same. So there is no multiplication here. There is no common growth factor. So if there is no growth factor, is there something number added each time? So 6 to 10, you can add 6, you get 12. 12 plus 6 is 18. And there you go. You can clearly see the rate of change. That is a common difference is there. And that's why this is the arithmetic sequence. The next one they give you is, can I make it a little bigger? Okay. So first one, complete that. It is arithmetic sequence. Now, if it is arithmetic sequence, that means there is a rate of change. There is a common difference. Now, from here to here, what is added to minus 3 to get minus 2? And you can see on the number line, it is minus 3 here, and this is minus 2 and minus. So the common sense clearly says from minus 3 to go, you just have to add plus 1. So each time you add plus 1. So that means it's minus 3, then minus 2. So what goes right here? And you can see from here it has to be minus 1. Add plus 1 and you get 0. And then add and you get the answer. The next one, or if you do not want to, let's say you don't want to show with the help of a number line, then another way to check is always do any term minus previous. That's all you do. So that's like this is any term minus 2, and you subtract the previous one, which is minus 3. So 2 negative makes it positive. So negative 2 and positive, you get the answer, which is the rate of change, and you're done. The next one, look at this one is 13. So from 13 to 25, how much increase? And you can see it is plus 12. So that's the common difference, the rate of change. So when you go to the right side, you want to add, you have to add plus 12. So from here, if you add plus 12, 25 plus 12 it gives you 37, and you add another 12 plus 12 gives you 49. But when you go backward, you'll have to take away. So instead of adding 12, you'll have to take away 12 here. So which will give you 1. And then the next one, C problem. The C, look, watch this. Now, in this case, it starts with 1, right? So let me make a table here. This is C, so I can write Cn, the name of the sequence. And you are given 1, 0.25, and then the blank, and there is a minus 1.25, there's another blank. So from here, what's going on is, you can see it's like a $1 and reduces to a quarters, 1/4. That means you're subtracting 3/4, 75, right? When you get confused, you can put like this. You just put 1 and then take away 25. It is 0.75. So that's minus. So each time you're taking away minus 0.5 or 3/4. And that way, when you take away from here, it will become minus 0.75. So I made a mistake here. This should be, when you reduce this one, this will be 0.50, okay? And then you take another one minus 0.75, then you'll get minus 1.25. So check that out. Let's do the fourth example. The sequence starts with the term 1 and 10. So that means the first one is 1, and the next one is 10, right? So 2, and then 3, and then 4. And I'll call this as, find the next, if it is arithmetic. So this is like arithmetic. So let's write, because it is arithmetic, I'll write an and 110. And you can see how much you are adding is plus 9, because 10 minus 1 is 9. You add plus 9, that's 19, and you get the answer plus 9, and you get 28. Next two terms, if it is geometric, so what does this geometric sequence means? Here you are multiplying by what multiplies to 1 to get 10, and it is 10. So that means your numbers will be changing. This won't be there. This is for the second one. This is for the B. So you multiply 10, then 10 multiply 10 will be 100. Again, multiply by 10 will be 1000. You're done. Find a sequence that if it is neither this nor, that means you don't want that it should be the same multiplied. So if you can start with a new table, and then you can say, okay, this is 1 and 10, and then okay. So first you can see, I'm gonna write this is 9, right? So if I'm 9, this is plus 9, I can write this as maybe 10. So I will 10 plus is 20. See? So here you're adding plus 10, but here you're adding plus 10. So they are not the same. So this is not arithmetic. Here you are multiplying by 10, but here you are multiplying by 2. So the common ratio is not the same. And this is how you do problem number 4, 5. So each is a geometric sequence. So because it is already geometric sequence, the first one, let's say, what multiplies here is 5 times 5 is 25. Or I can make a table. Okay. So what they give you is they give you the second and the third, 5 and 25, and there's a blank here, and this one is given, right? And this is, because it is A, I can write this as N and A, and also you can use the lowercase also. So that means this is the first term, second, third, fourth, and fifth. And then you can see this, what multiply, because it is a geometric sequence. The good thing is you already know it is 5. Why? Because 25 divided by 5 is the common ratio, which is a 5, which is the growth rate. So if you are multiplying 5, you just multiply another 5 and you get 125. And you can clearly see if you multiply 5, you get this. And when you go backward, you will have to divide by 5. Instead of multiplying 5, you will have to do 1/5 of 5, which is 1. That's how you do. Check the next problem. The second one here, it is minus 1 first. There's a blank, then minus 36, then 216 in blank. If you see this, what multiplies to get 6? So 36, 30, how many 36? So you can check. So it looks difficult. So 216, so 216 divide by, so this is the better way to do. And you can use your calculation here. And 36 times, I think it is 6 so times 6, 6 are 36, 6 is 89. So you will see that the answer is minus 6, that there is the growth factor, which is r equals minus 6. So if I multiply by minus 6 again, you get the next number, 216, and again you multiply 6 times 6, 36, 3, 6, 1 are 6, 7, 8, 9, and 6 is 1, 2, 1, 6. But remember, there's a minus. That is minus 2 ones. But when you go backward, or you can just multiply here on negative 6 and you get the answer, which is plus 6. Okay, so yeah, I'm rushing with this and because quite easy. This is lesson number 3, and I'll make a video on lesson number 4 also, so that uh, we know what is happening. And let's see. Hmm? Okay, what about this third one? So you multiply by half, so it is 10 and it is 1. Okay, so you can see 5 divided by 10 is half. So you are multiplying by the growth factor half. So so what is half of 5 is 2.5, and half of this is 1.25, and half of this is, and you can get the answer. Then what happened, baby? The D, almost we are there. So this one is, you'll have to first do negative 108 divided by 36. So three of them makes it, I think it is negative 3. That's the common ratio. And so you multiply this by minus 6 and you get the next one. But you have to do this side. You have to 1 minus 1 6. So I have to, so minus 1 6. So minus 1 6 will be minus 6. And then again minus 1 6 will be plus 1. Check that out. And then finally, the last one is a little tricky because it has, if you see this 18 divided by 12 is like a 3 over 2, right? So it means each time, so we don't know the first one, that's a blank. And they gave the fourth and fifth is what you're supposed to write. This is 12, 18, and 27. So from here you multiply 3 over 2, and then you multiply 3 over 2 here, you get the answer. So that means this will be, if you multiply 3 over 27, will be 81 over 2 there. But when you go backwards here, so this one, you will have to multiply by this one. Instead of multiplying, this is multiplying 3 over 2. But when you go backwards, you are multiplying 2 over 3. So that means this is 12. 12 times 2 over 3 is 3 goes, 3 divides 12. 4 times 2 is 8, so and you get answer 8, and you're done. So hope that helps. And almost last two problems. Okay, the first term of a sequence is 4. Choose the growth factor. So we can pick our own and to have a geometric sequence. So maybe I'll try to do 3 or minus 3. So start with 3. The first term is 4. So this is the first, second, third, and fourth. And you want to write 3 more, and I can call this as n. And you want to have a geometric sequence, or Gn. So I'm using negative 3. Multiply negative 3, you get negative 12. Again multiply negative 3, you get positive 36. Again multiply by negative 3, and you get negative 108. And you get the answer. Choose a different growth factor and list. So you can select maybe minus 2. This could be, it doesn't have to be what I chose. You can choose, okay, let me take half of it, or maybe 1/4 of it. So 1/4 of 1 will be, so 1/4. So you can select 1/4 also. 1/4 of 4 is 1, and then again 1/4 of 1 is 1/4. And then again 1/4 of this will be 1 over 16. And hope that helps. The last one of this is, okay, here is a rule that you use to build a sequence. I'm starting with a number chosen. Each number is 2 times 3 less. Now I want you to take care 2 times and 3 less. So that means the previous number. So let's select a number. 1, 2, 3, 4, and let's select simple example 3. And then let's see what is the next one. It says 2 times. So that means 2 times 3 is, so multiply 2, 2. So 2, so this is the 3, and you multiply 2, and then you decrease it 3 less, so minus 3. So 2 times 3 is 6. 6 minus 3 is 3. Then again, and if you see it, you go on getting 3, 3, the sequence like this. But let's take a different one. Let me not take a 3. Let's select something different, maybe 4. If I select 4, so multiply 2. So this means 2 times the previous. So 4 times 2 is 8, correct? So you multiply with 2, you get 8, and then you decrease by 3, that becomes 5. Again here, you multiply 2, which is 2 times 5 is 8, and then you decrease by 3, and you get again 5. So it's like you start, whatever you start, but then it goes, it repeats the same things. That's a nice kind of a pattern there. So multiply this by 5 times. Oh, I'm sorry. You multiply 2 to 10. 2 times 5 is 10. This is 10 minus 3 is 7. So sorry about it, 7. I'm doing it so fast. So this is going to be 7. Then 2 times this is multiply 2 and decrease by 3. And 14 minus 3, and you get 11. And that's how you do, okay? And this one also start with, oh, they already gave us. So you start with 0, build a sequence. So they already gave you what to choose. And I hope this will help. So thank you for watching this. As I said, this is lesson number 3 and practice problem from problem 1 to 7. And this is unit 1. Okay, so this completes. So the next homework I'm going to do. So these are the things what I like to do is I want to create. I want to complete all the practice problems on each lesson. So this is 3. So the next one I'm doing it. Lesson 4 is excluder, so we do go direct to lesson number 5. Thank you for watching and hope you guys do well for the quiz.